Welcome to springlib.
Okay, we have the following molecule. It is an 8-membered ring. And we have a double bond here, a double bond here, a double bond here, a lone pair here, and a negative charge. And the question is this a cyclic conjugated system? And if so, how many electrons are in it? Then, is it aromatic, anti-aromatic, or not aromatic? Recall that to be a cyclic conjugated system, we must have an unbroken chain of sp2 hybridized atoms, or atoms that can readily reconfigure themselves into sp2 hybridization in order to gain the increased stability of being aromatic. In this case, every atom in this molecule is carbon, and recall that to be sp2 hybridized, carbon must either be partaking in a double bond, a triple bond, or be a carbanion, a carbocation, or a carbon radical. And what we'll notice is that for 7 of these carbons, 1, 2, 3, 4, 5, 6, 7, that is the case. We have a carbanion, and the remainder of the carbons are participating in double bonds. This carbon, however, is neither, and in fact, we know that there are 2 hydrogens on it, 2 implied hydrogens, given that all carbons have 4 bonds, unless they have a charge or are have something else denoting perhaps that they're a radical or a carbocation. So therefore, this carbon cannot be sp2 hybridized. In fact, it is sp3 hybridized tetrahedral, which means that this cannot be a cyclic conjugated system because we do not have an unbroken chain of sp2 hybridized atoms. So the answer to part A for this molecule is 0, which is what we're supposed to put if it is not cyclic conjugated. And by default, then, this is non-aromatic Na. Let's take a look at our next molecule. Now we have a 6-membered ring with an oxygen in it. And we will see a similar thing happen, a carbon, which has only 2 explicit bonds and no charge, which means that there are 2 implied bonds to hydrogen, which is a carbon with 4 bonds, which is sp3 hybridized, which means this cannot be cyclic conjugated. A is 0, B is Na for non-aromatic.